Hello, Forecaster here again, and we are back for episode 53 of the Railcraft server Let's Play. And as usual, we are not currently on the server. And in this episode, we're going to be doing something a bit different as a bit of a break from the reactor stuff, mainly to give me more time to make preparations and plan some things, of course. So, people usually ask what the current season is on the server, mainly to avoid the winter season, which is pretty rough with tough as nails. And what we're going to do is we're going to create a website that is going to display weather and season information from the server. And we are, of course, going to use Open Computers to send this data from the server to the website. So this video is going to contain Lua, of course, as well as PHP and some JavaScript and HTML and CSS probably. And I don't know how many episodes this is going to take, but we're going to see this through is the plan, and I'm going to show you the entire process basically to get this working, and hopefully it will actually work out. It would be good. So we are currently in my single player test world, of course, and not actually on the server. It would be a very sudden desolation of the server world if it looked like this, because here I can manipulate the weather and seasons freely without disrupting the server. So the equipment here, we have a bunch of sensors, and the first four are the season sensors from Tough as Nails. So we have the summer sensor. Actually, no. We have the spring sensor, the summer sensor, the fall sensor, or autumn sensor as it's called. It doesn't say the name of them in the block name, but it has the name in the ID, which is weird that the name isn't updated. You make one of these, and then you shift click them to get the different sensors. But it could still update the name. And then finally we have the winter sensor, of course. And as you can see in this world, it is currently spring. And I think time is stopped. Yeah, I've stopped time. The daylight cycle is off, so I don't think the seasons advance. We're going to have to, but I can set the season with a command anyway. Then we have the weather sensor from Quark, I think. Yeah. And then we have the vanilla daylight sensor, which you can toggle to a moonlight sensor. We could actually have one of each of these. Let's add a moonlight sensor as well, because, well, you'll see. And then, of course, we have a creative computer here with OpenOS on it, and a bunch of redstone IO blocks. And we're going to write a program in Lua, which is going to sit on this computer. And it's going to wait for redstone events. So basically these sensors, when the redstone signal changes, it's going to output into, because they output to all sides, they're going to output into this IO block, which is going to create an event once any of these changes. And then we're going to, when that happens, we're going to check all of these, what the current signal is, and send an update to the server, to an API that we're going to create, which we'll get to later. Now, the first thing we're going to do is we're going to get the addresses of each of these. And let's pop over to IntelliJ, where I have created a new program called Weather Updater. And we're going to proxy each of these. That's not, need to click to copy the address first. So we're going to have, let's see, summer, and then we're going to have autumn and winter, weather, day and night. And then we are going to have a proxy for each of these. And then I'm going to just going to go into the game and copy each of these addresses from each IO block, put them into the proxy statements so that we get connections to each of these. Now, we could do an event for each of these, but I'm just going to, I mean, we have two options, basically. We could either do a loop that runs, say, once per 10 seconds or something like that, because I don't think the weather updates need to be that frequent. Or we could have it update whenever it receives a redstone change. I guess we could have it do specific. I mean, we have three choices, I guess. We have the timed loop, which just checks all of them every X seconds. Or we have we look for a redstone event, and then on any redstone event, we check all of them. Or we check for a redstone event and then check the specific one that updated based on the address, I guess. I'm not entirely sure which one I want to do. We're going to create a run variable, and then we're going to do while run run stuff, just a loop to keep the program going. I think we want an OS sleep, actually, and then we can sleep for 5 seconds. Because it's going to be event based, we don't really need the program to do anything in the loop. So if we create a local function on redstone, and we're going to pop into one of these other programs to steal the event code, or the event arguments, because I never remember them off the top of my head. So basically, I think the sender will be, I'm not entirely sure, but it should be the same. If it's a network event, the sender is the address of the sending network card. If the event comes from a component, presumably, say a redstone IO block, the sender would be the address of that IO block. So I think what we're going to do, instead of doing this, we're going to remove the proxy part from each of these and just store the address in the variable. And then what we can do is local redstone and then proxy sender, and that's going to try to connect to the sending redstone IO block. And then we need the side. So we're going to sides require sides, and then we're going to do a local common side, and then we're going to say, and if we go back to the world, the sensors are on the east side of the blocks. And since all of them are on the same, we can have just one variable for all of them. So east, and then I think it's just a side. So sides, then common side, we'll send that in as a key. And input. So there we have that. Then we basically want to send that as a request to the API, because we haven't gotten an API yet. Let's formulate the data anyway. So I think what we can do is we create a table, and then it's always difficult to remember the syntax of tables between different languages, or like objects like this. But I think we want actually, we're going to change this up. So instead of doing a variable for each type, we're going to do one variable called inputs, and that is going to be a table, and then we're going to have the address be the key, and the value be the... Okay, that's not how you do it. Was it equals? No. I do not remember what the syntax is for this. Pretty sure I defined a table in one of these. Didn't I? I have a file with table in it somewhere. Ah, right. Okay, so no quotes around the key. And then an equal sign. don't know. That's probably not going to work when the... This is tricky. I mean, I guess I could just do this. Would work. Yeah. Actually, no. That's produces an error as well. Oh, right. I want to do that. And then that. Yeah, there we go. And then we're going to copy that. And that is going to be that. Autumn. Try to make this as dynamic as possible so that we can have as few checks and if statements and junk inside of the sending code. Winter, weather, and then day, and night. That way. Whoops. Dang it. There. All of these should be different now. Yep. I think that's correct. And we actually don't need these anymore, so I'm going to remove them. So, what we're going to do in data, whoops, we're going to say type equals, and then inputs, and then sender. So the sender has the address, and we'll pass that as a key to inputs, and we'll get one of these back, and then we'll set that as the type, and then we'll send in a value, which is going to be data, which should contain the redstone value, I think. Actually, the they don't, it's not going to have these. I don't actually remember what the parameters of the redstone event is. We're going to have to check that. So what we'll do is go into the Lua prompt and then event pull redstone. And then if we fake no? Oh. That says redstone. That's not what we want. Come on. Exit. Ah, dang it. Stupid thing. Okay. Let's do this instead. Let's do an OS sleep 2. And then print event pull like that. If I didn't have the OS sleep, it would catch the key event when I press escape to close the interface. Okay, there we go. There's our redstone event. So the event is actually called redstone changed, which explains why redstone didn't work. So, okay. Now, that address that we saw there is the address of the... Okay, so the parameters actually look like this. I think that. So we don't actually need that. That just needs to be data. We don't actually need to get the value because we receive it in the event. That was silly of me. Now we are going to pop into here, and then we're going to actually we can just look at the documentation. In the Internet API, we have a request method which takes a URL to send the request to, and then a data which can be string or table, and yeah. So I shouldn't do that. Should not do that. So we're going to need to require the Internet API. Local net equals require internet. We have an internet. I have put an internet card in the creative computer. And then we're going to do net request. And we don't know the URL yet. But we have the data, which is a table, which we're just going to send. And I don't think the updater needs to know if the request was successful or not. So there we have that. We're also going to local function on interrupted, and we're going to set run to false, and then we're going to need to initialize run above that function so it knows about it. And then we're going to, we are actually going to need to require event. The event API is rather useful. And then event listen redstone change on redstone. And then event listen interrupted on interrupted. And then after here, we're going to want to event ignore. Actually, we can just copy those. And then ignore both of those. Then we can print program terminated. So yeah, this doesn't really need to wait any amount of seconds. It can just yield every tick. I think that might actually be more efficient. Not sure though. So there's our program. Now I've already, we don't even use the sides API anymore. Remove those references, I guess. We don't really need that either. This became a little more compact than I thought it would be. Anyway, I've already linked this to the world, so if we pop back into Minecraft, we're going to exit the Lua prompt. You'll see that we have a weather updater file here, and if we edit it, you'll see that it has the stuff we just wrote. So that's basically running now. Of course, it's not actually sending anything anywhere because we didn't specify a URL. So we're going to terminate it, and we're going to pop back into IntelliJ. We are running out of time though, so we'll probably start on the actual API and the site side in the next episode. But I have created a project for that already, and we're going to we'll create an index file. So I want a PHP page, and we'll call it index. And this is a template that I've created that creates some stuff. And you can see that it's called Forecasters Forecasting Services, or FFS for short. And this is going to be the basis of our weather system. And this is going to be the page that will display the weather information. And we're going to create a file that will receive the data from the Minecraft server, from the OC computer, and store it. And then this page is going to load that data, and then we're going to use some JavaScript, a little bit of JavaScript to update it, so you don't have to keep reloading the page. It's just a nice, convenient feature. So I'm going to end the episode here, a few minutes early, but that's fine. And in the next one, we're going to get started on this side. So I will see you then.